I'm J.D. Baker. I'm from the Department of Anthropology at UHML, and I'm a medical anthropologist, and I've been doing research on AVA now for 10 years, I think, 15 years almost. So involved working with the folks at Shamrock as well, and doing my own research on it.
And I go by Chris from University of Minnesota, and I've been working on Kava for close to 10 years, and I'm here to learn, really to share what we know a little bit about Kava, but more importantly to learn the knowledge that have not been reflected in literature. My knowledge about Kava is all through reading the publications, and sometimes watch the YouTube, but I have never really get first-hand on this. So more importantly, as I've talked with some of us, I'm here to look for more opportunities, to look for what can we do as a team to move forward.
Now, Chingo or Chris has done a number of publications on AVA as potentially suppressing the formation of lung cancer and colon cancer and bladder? Prostate.
There is some research out about bladder cancer.
Right. No, that's not mine.
Yeah.
Right.
Okay. So I wanted him to elaborate for us the status of that work and what he thinks their next step is going to be at the University of Minnesota. My correspondence with him indicates that it's very positive.
And I got interested in Kava not because I understand Kava, but once again I was reading and something happened to me. I was a report talking about the cancer incidence rate and the Kava consumption, and in that paper, which is published in Hawaii Medical Journal 2000, and that basically suggested there are several nations in the South Pacific Islands that have very low cancer rate and associated with fairly high Kava consumption, and that paper just speculate that Kava might be the reason for that, or to put it another way around it is Kava may actually help to reduce the cancer risk. So that's pretty much what stimulated me to work in this field. And to test that, basically we put the Kava in the diet and feed it to, at the current stage, to mice, and those mice basically they are either have some thing mess up with their genes that they will develop cancer just naturally, or we gave them some chemicals, and one of those chemicals are actually from tobaccos, and we all know tobacco is the major cause of lung cancer, and part of the reason, at least the current understanding, is that chemical will cause DNA damage, basically mess up our genetic materials and leading to the initiation of lung cancer. So using really 3 animal models, we have demonstrated that when we put the Kava in the diet, feed the mice or rats, they will have low cancer incidence, including lung cancer, colon cancer, and prostate cancer. Particularly for the lung cancer, we recently published the data. Basically, Kava can block 99% of tumor multiplicity, or the tumor numbers. Okay, so that I have to. Basically, that's very surprising that a naturally occurred, we call it a dietary supplement or a plant or natural product, can show such a level of efficacy. And this has never been observed in literature at all. So we are extremely excited about that. And with some follow-up work, we think we are close to understand how it works. Really, as I mentioned, that the chemicals from the tobacco product can mess up our DNAs when we smoke. And what Kava did is actually really prevent that process, really stop the beginning process. And what my argument is, that's probably the most effective ways to prevent cancer development, because we stop the origin, not doing the process. And what my philosophy or thought about fighting against cancer is we stop the origin. That's the most efficient ways. When we let it start, we are fighting. Cancer becomes more and more aggressive, and we will have less and less opportunities to really fight against this. So that's why I feel like this is a very promising discovery out there. And we also think we have identified what is in Kava that is responsible for that. And that data has been just submitted for publication. And actually, I shared that data when I was at Fiji and also yesterday at the University of Hawaii as well. So really right now, at least based on our current data, we can somewhat speculate what compound we should look for among different cultivars. Of course, this is just beginning. There's a long way to go. Back to that, if we feed the mice with that Kava product, and then for a few days, then we gave them a dose of Tylenol or acetaminophen. And of course, Tylenol can induce the hepatotoxic risk, but the priming the mice with Kava actually seems to enhance that risk. So that's where we are right now. And from that aspect, we also think we know what the active compound might be. And it's not the compound that reduces the cancer risk for lung cancer at least. So right now, our goal is really not only for cancer aspect, for anxiety, for other aspects as well. We really would love to, from a chemistry point of view, I'm a chemist, I really want to know what is a chemical responsible for its beneficial effect? What is a chemical potentially responsible for its adverse risk? Then with those information, we could work together to say, what is the Kava cultivar we should be growing? And how long should we grow it that we will maximize the content of the good stuff and hopefully really reduce or eliminate the bad stuff. So the ultimate goal for one direction is we hope to provide a set of information that can help to standardize the Kava product on the market. And so for the prevention aspect, we are extremely excited, and one direction we are pushing is to we have done it in mice, we are doing it in rats, and the preliminary data at this stage suggested it would work in rats as well. So with these two strains of data, we believe our next goal is to move into clinical aspect to humans. And there are multiple ways that we can potentially explore that. And that's another thing that I feel like I'm very fortunate to have a trip down here. Really, one thing we would love to is to collaborate and to collect those clinical data from a small pilot scale to test the proof of principle. And with the outstanding efficacy, with a little bit of pilot clinical data, I think FDA will be, we are in a process to get in touch with FDA, really submit our data out here we have right now, and really ask, what do we need to do to sort of get FDA on board, because FDA issued a warning about 12 years ago, and that was it. They never follow up on that. And every funding agency or every public media will say FDA has a warning on it. And we hope that our data will at least try to get FDA engaged a little bit in this aspect. Now we can figure out what, from a safety point of view, what FDA's requirement would be, and then we will, with their input, I hope we will get their input. It's a very hard thing to predict how they are going to respond to it. But maybe at some point we would love to have my voice. They give, they pay no attention to my voice, but if the voice comes from different directions, then maybe they will be a little bit more serious about that.
You mentioned is it a cavalactone specifically that would potentially prevent the cancer? And then you say there's something else in there if it's mixed with Tylenol.
Right.
Something else in the AVA.
Yeah.
That's not going to bother you if you're just drinking it by itself.
Yes, that's based on all the data we have. We have done, mice, rats, short-term, long-term. The long-term we did is up to 7 months. That's pretty long for a mouse of 2 years of lifespan. 7 months translate to human, that's about 20, 30 years. We saw no signs of adverse effect, particularly for liver. We didn't really look into other aspects that carefully, but we focus on liver. We haven't seen any signs of adverse effect. So,
2 questions. Did you feed the rats or mice the cavalactones with Tylenol or separately?
separate.
Separately.
So we need to, the reason we did it okay, let me tell you a little bit how we did it. We tested Kava for, quite a long time. We didn't see any signs of adverse effect. So we sat back and tried to think about what might have happened in Europe, about the risk. So we it's an imagination, okay, because you just sit there and think. And what we came up was, Kava might be consumed by the Europeans on a daily basis. But then all of a sudden they got a headache or some sort that they would take some medication. So that's sort of the scenario we are kind of thinking, and that's why we primed the mice for a few days, trying to mimic the daily Kava consumption in Europe. And we say, okay, follow it up with a dose of 7 months.
Second question, thank you, number 1. Second question, when you fed the mice, did you feed the mice an alcohol extracted food, or was it a water-based extracted Kava product?
Very great question. It's alcohol-based extraction.
Yeah, that's okay.
Right.
Good.
And the reason we use alcohol-based, first of all, it's really not that feasible to use traditional water preparation for mice,
right,
because based on my very short experience, the traditional preparation of Kava is not a clear solution. It has small particles in there, and that is extremely challenging to administer that to mice. You cannot let them drink because it will stuck the bottle.
So,
And they won't start it off to drink it.
So it was a tincture then you fed it?
Right. And the other reason we use this ethanol extraction is we get bulk quantity that we can maximize our chance of our reproducibility. The one that we did last year, we used the same batch to do this year, reduce the.
So talk about what you did to analyze the extract that you did use, because you didn't just use it, you looked at what, you tried to characterize it too,
Right. And
to see how it compared to like traditionally prepared.
Right. So basically, we did compare it to the traditional preparation, and the chemical profiles are quite different.
Oh,
And the compound that is potentially responsible for the hepatotoxic risk is in much higher abundance in the ethanol extract relative to the traditional preparation. And that's actually one area that we think need to be addressed as well, to really chemotype, barcode these different chemotypes. And right now, at least based on my understanding, all the commercial kava products are standardized to the total kava lactone. Okay, they don't care about anything else. Even among these 6 total kava lactones, they look at the sum, not the real profiles. I think the standardization out here right now is very, very crude, and the products on the market have literally minimal quality controls because we analyzed 14 of them. But basically, we analyzed those 14, it's all over the place. It's really all over the place. Right.
I'm curious about the mechanism of hepatotoxicity. Have you looked for P450 induction or anything that might potentiate the metabolism of acetaminophen?
Acetaminophen? That's what we are probing right now. Yeah, you're right. There were quite a lot of discussion about kava can inhibit CYP enzyme, which is the enzyme that metabolize all these drugs or help to detoxify some of these drugs. But there were also quite a lot of studies showing that kava can induce some of those. So, and many of those studies, the dose they are using are, I'm a little bit concerned whether they are physiologically relevant. They are using like made micromolar or microgram per mil. That's probably never going to be achieved
I can't remember the enzyme that makes NAPQI from acetaminophen. I think 2C19 or something like that.
I don't remember.
It would be interesting to.
Right. So what we are doing right now is we are profiling a whole panel of CYP enzyme, phase 1 enzyme and phase 2 enzyme. And based on that, we can look into that a little bit more there. Right. And we are also trying to look at whether, the kava priming change the metabolism of acetaminophen. So, right.
But it's important, it seems to me, that the original inspiration for all of this came from traditional users. And they're not sitting around every day drinking 2-day kava.
No.
So if their cancer rates are less, then potentially the cancer rates could be less for people that just drink regular daily consumption.
That's exactly what the API data is based on. It's not based on the commercial usage of kava, it's based on the traditional use. So yeah, definitely if we trace back to really ask the question about the cancer risk, those are reflected, at least based on the API data, reflected by the traditional use, not the commercial use.
And one of your papers talks about methysticum, the specific catalactone methysticum as possibly being something that suppresses tumor.
Right.
Okay.
Right. Actually, our in vivo data shows methysticum is not as good as dihydromethysticum, but methysticum is active. Right now, we don't know which one is more active because the study is not to the level, that we should do to differentiate those two. But both compounds are active. But we have done more work with dihydromethysticum.